Erica Carlson, a theoretical physicist at the Purdue Quantum Science and Engineering Institute. Welcome to Quantum Coffee Break, bite-sized nuggets of quantum-y goodness you can enjoy with a cup of coffee. You've probably heard the idea that a quantum mechanical particle can be in two different places at the same time. I don't know about you, but I would really like to learn that trick. One reason is because when I look at my calendar, I sometimes find that I have committed to be in two different places at once, or sometimes even three different places at once. So I would like to learn that trick for myself. How is it then that quantum particles can do something like that and be in two different places at once? We've talked before about how quantum mechanical particles have associated with them a wave. Sometimes we call it a wave function. Now, in most places in space, that wave is zero, it's flatlined, but there'll be some place where that wave is wiggling and then goes flatlined again. The place where you're most likely to find that particle is somewhere in the wiggly bit. And in fact, the shape of that wave tells us all the properties about what the particle's doing. It tells you where you're likely to find the particle, what its energy is, what its momentum is, things like that. Now, a wave can, in principle, take any shape you like. So let's think, for example, about how we might make a particle that's in a wave on the left-hand side of the screen. What shape wave would I need? I would need a wave that's flat in most places and then wiggles a little on the left side of the screen. How would I make a wave associated with a particle on the right side of the screen? I would make a wave that's flat in most places and then wiggles on the right side of the screen. Now, since it's a wave, there's nothing wrong with making a wave that wiggles in more than one place at once. So let's think about a wave that's flatlined and then wiggles on the left side of the screen, flatlined again, and then wiggles a little on the right side of the screen. Where am I likely to find a particle in that state when I go to look for it? I'm likely to find it in the wiggly bit on the left-hand side, and I'm also likely to find it in the wiggly bit on the right-hand side. So that's how it is that a particle can go into a state where it really is in two places at once. It simply makes its wave wiggle in those two different places. Now, this would solve not just my calendar problem, but if I could bring this into my everyday life, it would also solve the problem of the movie theater date, right? My husband and I have been married for 27 years, and we still have this issue when we go to see a movie together. Where do you want to sit? Oh, I don't know, next to you. When what I really mean is, I want to sit in the front row, but he wants to sit somewhere in the middle. So how would we solve this if we were quantum mechanical particles? We could make our wave wiggle a little bit in the front row. You could also have it wiggle a little bit in the middle row and have it wiggle a little bit in the back row, and then you could sit in three different places in the movie theater at once. Problem solved. So, can I pull this off in my everyday life? Alas, no. There's a constant of nature that controls the size or the prominence of quantum effects. It's called Planck's constant, and it's a pretty small number. That's why quantum effects, we can see them in tiny objects, but to try to see them in large objects is rather difficult. The effects just aren't big enough to be seen prominently in our everyday lives. So we saw that a quantum mechanical particle can be in two places at once simply by making its wave wiggle in those two places at the same time. Now, you may have the question, where will I find this particle when I go to look for it? Will I find it in both places at once or only in one of those two wiggly bits? And that brings up the whole question of measurements in quantum mechanics. We'll start talking about measurements next time. I'll see you then.